Equations of linear functions. There are several forms that the equation of a line can take. They may look different, but they all describe the same line. All linear equations describing a particular line are equivalent. Right, so we have slope-intercept form, and in slope-intercept form, the m refers to the slope, and b refers to the y-intercept. We have standard form, and in standard form we don't learn the slope, we don't learn the y-intercept. It's useful if we want to vary two quantities. Like, so for instance, if we wanted to know if cherries cost $5 a pound and apples cost $2 a pound, and you had $10, how many pounds of each of those two could you get? So we could look at different combinations. That's what standard form is useful for. Right? So it's useful for looking at different combinations that equal some constant. C there is a constant, and A and B are integers. Right? And then we have our point slope form, probably the most useful form of all. M again is still the slope, and x1, y1 is just any point. So that's what makes point slope form so useful. We can use any point. We don't have to have any specific point. We can also solve for y in point slope form. So it's kind of a combination of slope-intercept form, where we have y isolated, and point slope form, where we could use any point, not just the y-intercept. And all you have to do is add y1 to both sides. So notice we have y minus y1 equals m times x minus x1. And if we add y1 to both sides, then it's on the other side. Right? So you should get used to seeing this format here, where y is isolated, because you will see this in later courses, particularly calculus. Right? You'll see, as you move on, you'll see point slope, and you'll see this kind of modified point slope here where we solve for y. You'll see those two forms the most. Let's do some graphing. Now that we've reviewed the forms that linear functions can take. All right, so we're going to graph in slope-intercept form here. Y equals 4/5 x plus 4. And make sure you're following along in your notes, right, and taking notes where appropriate. Some of these, you'll have this in your notes, so you can add some things there. And you have, actually I should add one thing right here. So here, m is still the slope. I should make that clear. And then the x1, y1 is still a point. And then over here, we are going to be graphing a few, and a couple of them are in your notes. And anything you see up here, I believe, is in your notes as well. All right, so we have y equals 4/5 x plus 4. We want to identify the y-intercept. It's easy to do when it's in slope-intercept form, and we want to identify the slope. All right, so our y, I'll do the slope first. Well, I guess I'll do the y-intercept because it says 1, identify y-intercept, even though I wrote it below. So our y-intercept is going to be right there, 0, 4, the point 0, 4. And our slope is going to be right there. So our slope is 4/5. You should write the y-intercept as a point, 0, 4. Don't just write 4, because you may accidentally graph it along the x-axis instead of the y-axis. If you write 0, 4, you're much more likely to get it correctly. All right, so now all we have to do is graph our y-intercept, so that's 0, 4. And then we'll use the slope to count out more points. All right, so we have 4/5. That means the rise is going to be 4, and the run is going to be 5. Right? So I'll count up 4, 1, 2, 3, 4, and to the right 5. 1, 2, 3, 4, 5. I can't count any more points to the right, but I could count some points to the left, because I could also write that slope as making them both negative. Right? Because the negatives would cancel. Negative 4 divided by negative 5 is the same thing as 4 divided by 5. All right, so now I can count down 4, 1, 2, 3, 4, and to the left 5, 1, 2, 3, 4, 5. And you see they're still on the exact same line. All right, so now all you have to do is connect the points, and you should use a ruler. I'm going to use so you actually have a straight line. I'm going to use a line tool so that I have a straight line because I can't use a ruler up here. Drives the board crazy. And I just need to straighten that out a little bit. So I'm actually going through my points. That looks pretty good. I think it needs to be a smidge, just a smidge. We'll take that. All right, so there's our line, and we should put arrows on our line because it's going to keep going in both directions. Speaking of where our line is going to, let's talk about domain and range. In all the functions we're going to be working with this year, we're always going to identify our domain and our range. And I believe I put the definitions there in your notes. Domain is your input. It's all the x values for the function. Right? So unless there's some reason we can't plug in an x value, for instance, it would make a denominator equal to 0, or it would be the square root of a negative number. Right? That's not going to be a real number. The domain is going to be all the values of x, all the real numbers. Right? So domain is all values for x. Here we can multiply any number we want by 4/5 and add 4 to it. So our domain is going to be, we can write it two ways. Actually, we can write it more than two ways, but we're just going to talk about two of the ways. We can write it three ways, actually. Our domain is going to be negative infinity to infinity. It means every single number, everything in between. Any number you can think of is good. Or we can write all real numbers. We also have a symbol for all real numbers. It looks like an R, but it has two sticks. The range is all the y values for the function. It's the output. So our range here is going to be negative infinity to infinity. Any number could be a y value here. And you can see if you look at the function, right, it's going to the right and to the left. We're not skipping anything. It's going to keep on going to the right and to the left. It's going to keep on going up and down, up to the right-hand side, left to the down to the left-hand side. Okay? All right, so here's our first one, and we went over a little bit more because we talked about domain and range. Here we have another one. Now we have standard form. All right, you have two choices here. You can either isolate y and graph using the x-intercept, or you could find the x and y intercepts and graph those. Either of those would be fine. Doesn't matter to me. I'm going to do both of those things. Let's graph using the x and y intercepts, and then we'll find the slope. So that way you know how to find the slope and the y-intercept, and you also know how to find x and y-intercept. So you could do either one. All right, so here we have 2x plus 6y equals negative 12. And we're going to plug in, to find the x-intercept, you're going to substitute 0 for y. All right, so we have 2x plus 6 times 0 equals negative 12. So 6 times 0, that's just 0. So I've got 2x equals negative 12. If we divide both sides by 2, we have x, I'll put it over here, x is negative 6. So our x-intercept is negative 6, 0. Write that as a point so you graph it in the right place. It's negative 6 on the x-axis, it's 0 on the y-axis, because we plugged in 0 for y. Now let's find the y-intercept the exact same way. We're going to substitute 0 for x. And I guess I should have written and solve on the other one. It was in my head, but I did not write it. So I'll just put real small here and solve. All right, so we have 2 times 0 equals, 2 times 0 plus 6y equals negative 12. That would just be 0. So 6y equals negative 12, and we'll divide both sides by 6. Trying not to hit the extend to page, but well, I did anyway. And so y is negative 2, and so the point there would be 0, negative 2. I did not mean to extend the page there, but I think we can still work with this. You can still see everything. I already have the domain and range up there because I know what it's going to be, because the domain and range is going to be the exact same thing for all our linear functions. All linear functions have a domain of negative infinity to infinity, or all real numbers, and a range of negative infinity to infinity, or all real numbers as well. So it's pretty easy to figure out domain and range. If you're dealing with a linear function, it's just going to be all real numbers. All right, so now let's graph our function, our x and y intercepts here. All right, so we have 0, negative 2, and we have negative 6, 0. And these numbers are a little pixelated, especially as they got smaller. And we just want to connect those 2 points. So we'll use a ruler, in my case a line tool. Oh, that was pretty close. Oops. Just move it up just a smidge here and down a smidge there. I think that's pretty good. And again, we want to put arrows because it's going to keep on going. And there we go. That's how you graph in standard form if you're finding the x and y intercepts. If we wanted to put this into slope-intercept form, all we have to do is solve for y. And I'm going to do the same thing. I'm going to do that right now so that you can see the steps and so we can check our answer. We'll be able to compare the slope and y-intercept. All right, so we have 2x plus 6y equals negative 12. We'll subtract 2x from both sides. So I'll put minus 2x there and minus 2x. So we have 6y equals negative 2x. Put that first if you want it to be in slope-intercept form. Minus 12. And then we'll just divide everything by 6. And so in slope-intercept form, our equation is y equals negative 1/3 x minus 2. That matches the y-intercept we got when we solved for it. And it matches our slope if we look. Right, we go down 1 to the right, 1, 2, 3. Right, and then down 1, 1, 2, 3. So we've checked our answer. We know that is correct. I have this feeling we have done this one. Yes, it got in here twice. Well, I don't know if there was another problem I meant to put in here, or this is just twice, but if there is another one, I'll put it in. I don't think so. All right, so here we have point-slope form. All right, so we need to know how to graph in point-slope form. We have y minus 6 equals negative times x minus 2. So very similar to graphing in slope-intercept form. Instead of graphing the y-intercept, we're just going to graph the point. Right? So a little reminder here, if x and y are negative, the coordinates are positive. So the formula for point-slope form is y minus y1 equals m times x minus x1. Notice the negatives are already there. So if we still see negative, we plugged in a positive number. If we see a positive number, it means we had minus a negative. That's what made it positive, and it's really a negative number. Here we see negatives, so that means those are both going to be positive numbers. Our slope is right here, right in front of the parentheses. So our slope is negative 1. Our point is going to be 2, 6. This is x, right? And this is y. The negatives stay with the equation. So the point is 2, 6. Right, so I'll graph the point 2, 6. So 1, 2, 3, 4, 5, 6 right there. And then we'll just use our slope of negative 1 to graph more points. Right? And we may find the y-intercept. In this case we will, but it doesn't matter if we find it or not. Right? We have a point and we have the slope we can graph. Right? So we can graph more points there. There's our y-intercept. So notice I don't take the time to put this in y-intercept form. There's no need to. I just graph it in point-slope. And you should be able to graph in all the formats. The only one that sometimes you might want to change, especially if you don't like especially if the x-intercept is a fraction, is standard form. Sometimes you might want to just change that to point-slope. To standard, to slope-intercept form. But on this one, just keep it as it is. And graph your point. It's almost always easier. And there we go. Put arrows because it's going to keep on continuing in both directions. Our domain and range are all real numbers, or negative infinity to infinity. Right? And that's all there is to graphing this one. Right? You just identify your point and your slope, graph the point, and then use your slope to get more points. Nothing to it. Right? And if you have any questions, I can help you, and we can graph more in any of the formats in class. Right, here I have another one in point slope form. Right, so we have y plus 1 equals 1/3 x plus 4. Right, so now we want to identify our point and our slope. The slope is right there in front of the parentheses. So our slope is 1/3. I see plus signs. That means that this equation is really y minus a -1. That's what gave us the plus, equals 1/3 x minus a, and I need another parentheses, I think. No, I'll be okay. Minus a -4. There we go. I got the right number of parentheses. All right, so that means the point is -4, -1, right? Because this is the x, right? We're adding it to x, so this is the x coordinate, and this is the y coordinate. So our point is -4, -1. So we'll graph the point -4, -1. We have a slope of 1/3. So it goes up 1 to the right 3, 1, 2, 3. Up 1 to the right, 1, 2, 3. Up 1, 1, 2, 3. And so forth. I usually graph as many points as I can fit. It just makes my line straighter. I would graph at least, I'd graph more than 2, unless that's all you have space for. But it's up to you how many you graph. But I do think it makes it easier to make a straight line. All right, there we go. So there's our line. Notice it's our y-intercept this time is not an integer. We'd have to put it in slope-intercept form if we wanted to know the y-intercept. But we don't need it to graph in point-slope form. All right, so that's all there is to it. We graphed the point, and this was the point actually we graphed right here. -4, -1, and then we just use the slope to get more points. Right? Nothing more. And our domain and our range, of course, this one looks like a fish, is -infinity to infinity, and that'll be true for all of our linear functions. Right, the last slide I'm going to look at is horizontal and vertical lines. Very easy to graph. You just have to remember their equations and how to graph them. And then I talk a little bit here about domain and range. Anything that's not in your notes that's up here, please add that. If you see my handwriting, add that, because that's important. All right, so here we have an example of a horizontal line. The equation is y equals 2. So if you have y equals a constant, that is going to be a horizontal line. There's no x. You could think of it as y equals 0x plus 2, and it has a slope of 0. Right? So notice that a horizontal line will intersect the y-axis, and it has an equation of y equals, m sounds like it's slope, but it's y equals a constant. And m there is meant to be constant. Since we use m for slope, I don't know if I like m for, oh, I have below there, y equals constant. All right, so when we're talking here, let's go, I'll talk about these notes here at the bottom when I talk about domain and range. All right, let me talk about the vertical line, and then we'll talk about domain and range for both of them. All right, so here we have an example of a vertical line, x equals 3. All right, so this is technically in standard form. So y equals a constant is technically in slope-intercept form. We just don't bother to write 0x. The equation of a vertical line is technically in standard form, because we could write it as x plus 0, y equals 3. Right? We don't have a y there, so it can't be in slope-intercept form. And there is no y-intercept. Vertical lines have an undefined slope. Right? They have a 0 in the denominator. So 0 in the numerator, that's horizontal. 0 in the denominator, that's undefined. Notice a vertical line will intersect the x-axis and has an equation of x equals n, and n is referring to a constant. X equals a constant. I don't think I need to have this here because I have it below. All right, so now let's talk about domain and range. All right, so now it's not all real numbers for domain and range. So for the horizontal line, the domain is all real numbers. Notice that I'm going from right to left there. I'm going to get every x value. But what y value am I going to get? Well, I'm only going to get 2. Right? I go through 0, 2, and I never cross the y-axis again. right? I never have, as a matter of fact, no matter what point this is, like, so say this is, let's say that's a -5. What would the y coordinate be? Well, that would be 2. And let's say this is 4. And what would the y coordinate be? Well, it would be 2. No matter what x is, y is 2. So our range is one single number. It's 2. Notice I have brackets. I had parentheses for -infinity to infinity, but brackets for the range. So parentheses means the number's not included. Brackets, the number is included. 2 is part of the range. You can't include -infinity to infinity because you can't actually get there. It's an idea, not a number. Right? It's the idea that it grows and increases and decreases without bounds. But 2 is really a number we get to. That's the only number we get to on the y, for y. All right, so if this is in your notes, add that to your notes. And then we have our domain and range for our vertical line. The domain is going to be 3. No matter what y is, x is 3. So maybe this point here, maybe that's 3, -4. And maybe this point here, maybe that's 3, 2. Right? So y can be anything, right, along that line there, but x is going to be 3 and only 3. So our domain is going to be 3, but this time our range is -infinity to infinity. So vertical and horizontal lines have restricted domain if you're a vertical line and range if you're a horizontal line, just because they only go through one number on the x-axis or one number on the y-axis. Right? So that's all we're going to be covering in terms of graphing horizontal, vertical, and other lines in this lesson. In the next lesson, we're going to look at writing equations of lines. Bye for now.